Well, it's great to see so many industry veterans and hanging out here at the end of the day. It's a little intimidating, but it's great to see so many people today here. So today we're going to talk about hyperscale and the future of flash storage. I'm Russ Stenford at Meta. There's Wei Zhang here. He is anchoring things today. And so for that, how about if we go ahead and get started here? So let's start, and we'll give you some background, talk about some flash building blocks, talk about flash systems. So it's going to be a lot of fun today. Meta. Some background about Meta. Our mission is to give people the power to build community and bring people closer together. And everything is focused on that and having the best user experience possible for all our customers. And so with that, let me start here and show, here's a picture of one hall in a data center. You see how we have many applications, 3.3 billion users. You see one aisle in a data center here. And this hardware is optimized to ensure the best user experience for all our users and just the best experience possible. As you can see, it's very dense, and we need to build as efficient hardware as possible to succeed at this. With that, let's talk about some flash building blocks. Let's start about, there's been lots of talk about form factors and all kinds of ventures in this area. Key hyperscale metrics around this, they need to be standard form factors. Power and thermal both need to scale. They need to be small, dense. Serviceability, hot plug, these are super important. With that, you see some trends from our friends at Trend Focus down here at the bottom. You see in 2021, E1S, volume is pretty small. Once you go to 2025, you see over 32% of the market is expected to transition to E1S. You'll also see that is, well over a very large amount of capacity, I should say, for E1S in that 2025. The question is, the out-of-control growth. What is driving out-of-control growth with E1S? You've heard about it all day yesterday, all day today. What is driving that? The reason for the strong adoption is not only is it standardized, it was very much designed from the beginning to be based on Gen 5 PCIe. It has excellent power delivery. The thermal solutions, there are many options out there. Customers can pick the right thermal solutions for their needs. And it's small and dense and excellent serviceability. If you haven't seen it yet, I encourage you to also go look in the Meta booth. You will see systems there with E1S drives. And so consequently, E1S adoption is strong as it meets the hyperscale needs. With that, let's talk about the Datacenter NVMe spec. This all started out with Meta and Microsoft starting a spec in 2019. In 2020, the 1.0 version was contributed to OCP. You can go pull that down today. Then in 2021, HPE and Dell also came in the mix. So between the four of us, there's the 2.0 spec that has also been contributed this year to OCP. And what's the purpose of this? The purpose is to align needs and requirements between the hyperscale, OEMs, and the suppliers. And by having this alignment, it drives great efficiency. The spec includes things like PCI Express, NVMe, smart logs, thermals, power, everything you need to build an excellent device in the data center type of environment. So now, you put these two together. We talked about E1S. We talked about the Datacenter NVMe SSD spec. What this means is now you marry the two, and the next generation now is ready to solve today's problems. And that's why you see lots of these things out on the floor when you go out there. You've seen many announcements from suppliers. With that, I also wanted to note in April, we did have an OCP workshop on NVMe SSD and EDSFF that had some hyperscale people. It had some OEMs. It had many NAND vendors. It's like 2.5 hours. The link is here in the presentation. If you go up on YouTube, you'll see more than 1,000 views of that presentation. So I encourage you, if you're interested in this topic, to go look at that, as there's a lot of great information there. Also, we have links down here to the 1.0 and 2.0 specifications that we talked about for the SSDs. And so there's a lot of great information here that you can go take a look at. And with that, let me hand it off to Wei here to talk about flash systems.
Can you guys hear me? OK. Hello, everyone. I'm Wei. By the way, thanks, Ross. I am a software engineer in Meta infrastructure. I'm going to talk about the flash systems. When designing the new generation of the flash platform, we begin with formalizing the requirements of such a system. And as you know, our previous generation of the flash platform is something called a JBUF. This is a project called OCP Lightning. It is a storage chassis connected with an external compute server through some PCIe cables. This time around, we want to design an integrated server. And it's better, just a lot of good benefits of having an integrated design. And furthermore, we want to design the system still support the hot plugs. And this is important for Meta, and in the sense of we have to replace these drives when it fails online without bringing down the server. We also want to design the system with the front-end loading SSDs. This will greatly ease the serviceability. Overall, we want to have a simplified design. We want to minimize the overheads that's in the hardware so that we can have an easier deployment experience. Now we look at the technology advancement in recent years and how would that help us to achieve the requirements or the goals that we have laid out. And Yosemite V3 platform is a single-socket compute platform. And it also supports a front-end expansion card. And this we can use to design the SSDs, plug-in cards. This achieves the goals of being front-end load. And the Cooper Lake CPUs we use has abundant PCIe lanes. It supports us to add up to 6 SSDs in the system. Furthermore, the CPU root ports currently can contain the PCIe errors and basically can support the PCIe surprise hot plug. Combining these two, this allowed us to eliminate the PCIe switch that was in our previous JBUF design. So we were able to greatly simplify the design just because of this advancement in the CPU. Now we look at the SSD industry, the NAND flash advancement. The NAND dies are growing larger, and this results in a single SSD capacity grows from 2 terabytes, 4 terabytes, 8 terabytes, now with 16 terabytes inside, right? This allowed us to build a denser box without drastically increase the number of SSDs in the system. So all these are coming together, allowed us to build a flash platform that we have in the YV3 flash system. And this is an internal view of the YV3 flash platform. On the left-hand side, this is a single-socket server, what we call Delta Lake. This is single-socket server design connecting to an expansion board. This expansion board, in the flash design, we have 2 flavors. The first one is a 1OU flash expansion card that can host up to 6 SSDs. These are EL.S 25mm drives. And this expansion board is codenamed as Warner Falls. And the other flavor we built also hosts EL.S 25mm drives. It's a 2OU expansion board. This can allow us to host up to 6 SSDs with a dedicated NIC. And this is a good choice for a flash server application. And this, we have a code name as a Sierra Point. So YV3 platform has this concept called blade, slides, and chassis. What you have seen on the left-hand side is a blade, what we call a servo blade. Now, if you stack up the 4 blades together, what you see on the right-hand side is a sled. And the top board is a shared NIC and also a shared BMC managing the 4 blade servers down below. So if you put 3 of these slides together, it's a chassis. And this is more obvious on the next slides. What you see here is a 4OU chassis on the top right. It's a 4OU chassis with 12 1OU blades. Right? This is what we call the waterfall expansion board configuration. It gave you the choice of put in 48 SSDs in this system. The bottom right is a 4OU chassis with 6 2OU blades. And these are the Sierra Point blades. This allows you to host up to 36 SSDs in one chassis. This design gave us flexibility in terms of matching the compute and flash ratios. It also allowed us to drive up the capacity on a single system. Excellent CFM port, support hot plug, and all the good things that we want when we deploy at hyperscale. If you're interested, by the way, you can please stop by the Meta booth at the hall, and we have a system there for you to take a look. I'll conclude with why this is a flexible system for our deployment. Right? In general, this is a common hardware building block. Right? It's easier because it's common hardware building block, it's easier to deploy at our scale. Right? And it also can be adopted by different flash applications that we are running. In general, you can categorize the flash applications in really 2 categories. One is more compute-intensive applications. These are like a database, RocksDBs, caching solutions like a CacheLib. They require a significant amount of CPU, memory, but not so great flash capacity. For these, we'll deploy them on a 1OU flash blade with low capacity EL.S drives. On the other side of the spectrum, there are storage-oriented applications, what we call like a flash storage server. These are exporting flash capacities to clients for them to use. These are storage-oriented. They need a higher density. They're not that much CPU intensive. They can really run on a denser box. For this option, we'll give them the 2OU flash blades with a higher density EL.S drives. So overall, this hardware design covers the full spectrum of our flash applications. Now I can turn this over to Ross and to close this out.
Sure. Thank you very much for coming today. So a few things to know. Hyperscale and the needs and solutions, they're clearly moving flash forward. We talked about how E1S solves clear hyperscale problems. We talked about the Datacenter NVMe SSD specification, how it's working at aligning suppliers and customers and the needs to make things more efficient. We talked about our YV3 flash systems, bringing it all together for excellent flash boxes for deployment. Also, I want to note, we have a monthly OCP storage meeting. I encourage you to come. If you have collaboration ideas, come talk to us. We're very much interested in collaborating with you on new and interesting, great ideas. I know with all the smart people in the room here, I know there are more good ideas sitting out there. I'm very confident of that. Lastly, I have a bunch of links here to things involving OCP, whether it would be our flash servers for 1 and 2OU, OCP SSD specifications. There's a specification for the E1S latch listed down there. There's also the workshop I mentioned. And so with that, We've been very busy in OCP, and we look forward to working more with all of you. So I really appreciate everybody who's here today. So with that, that's it. Are we taking questions? Or are we done here? Couple questions. Any questions? Anybody in the room? Any questions online? Wow, everybody's tired today. I understand that. So I want to thank you very much for all your time, and thank you.